NASA's $10 billion telescope just pointed at the edge of the universe and found something that has no right to exist. A black hole. Not forming, not growing, already massive. 300 million times the size of our sun. And it was there, blazing, 500 million years after the Big Bang, when the universe was just 3% of its current age. Scientists have one question. How? Black holes of this size take billions of years to form. The universe didn't have billions of years. It had almost nothing. And yet, there it was. And here's what makes this discovery personal. Because this black hole didn't just appear from nowhere. It came from the same tiny red objects James Webb Space Telescope found first. The ones nobody could explain. Remember the little red dots? Those tiny, impossibly bright objects James Webb Space Telescope found scattered across the early universe? Present only in the first 1.5 billion years, and then gone? Scientists couldn't explain what they were. Too bright to be normal galaxies, too dense to be star clusters, too red to match anything in our textbooks. Now, buried inside one of those dots, we found the answer. The galaxy is called Kuiper's LRDZ9. It's 13.3 billion light-years away. The light we see from it left before Earth even existed. At first, it looked like every other little red dot. Just a tiny smudge of red in a sea of nothing. Then, researchers at the University of Texas pointed James Webb Space Telescope's most powerful instruments at it. And the data that came back stopped them cold. There was a black hole at its center. Not a small one, a monster. 300 million times the mass of our sun, representing nearly half the mass of every star in its entire galaxy. Imagine weighing more than half your own house. That's what this black hole was doing to its galaxy. And the universe was barely 3% of the age it is today. The problem isn't just that this black hole exists. The problem is that according to everything we know, it couldn't have grown this fast. Unless something broke the rules. Here's the problem with this black hole. To grow to 300 million solar masses, black holes need time. Enormous amounts of time. They grow by swallowing gas, but they can only swallow so fast. There's a speed limit called the Eddington limit. Push beyond it, and the radiation they produce blows the gas away before it can fall in. At that speed limit, starting from the largest black holes that could have formed right after the Big Bang, reaching 300 million solar masses should take over 1 billion years. Kuiper's LRDZ9 was there in 500 million. That's like planting a seed on Monday and finding a full-grown forest by Wednesday morning. It doesn't work. Unless it started bigger. This is where last week's discovery becomes important. Remember Mitchell Beagelman's black hole stars? Those massive gas envelopes that let a black hole bypass the Eddington limit entirely? Kuiper's LRDZ9 has a thick cloud of dense gas surrounding its black hole. That gas cloud, absorbing X-rays, re-emitting red light, giving the whole galaxy its red color. The same signature, the same mechanism. What if the little red dots aren't just mysterious objects? What if they're the nurseries where the universe's first monsters grew up? And Anthony Taylor, the researcher who confirmed this discovery, said something that should shake you. This is about as far back in time as our technology can possibly go. We found the oldest, but we haven't found the first. Here's what we actually know and what it means. Kuiper's LRDZ9 was confirmed by an international team published in the Astrophysical Journal. Peer-reviewed, multiple instruments, verified spectral data. The black hole is real. The timeline is real. The impossibility is real. What the researchers believe is this: black holes in the early universe didn't grow the way ours did. They had help. Dense gas envelopes, direct collapse from primordial clouds, feeding mechanisms we haven't fully mapped yet. The little red dots, those objects that filled the universe for 1.5 billion years, then vanished, were the incubators. Each one potentially housing a black hole like this one, feeding rapidly, growing toward the supermassive black holes that would later anchor entire galaxies. The black hole at the center of our own Milky Way, 4 million solar masses, may have started exactly like this. A red dot, 13 billion years ago, that nobody could explain. Think about what that means for a moment. Every galaxy you've ever seen in a photograph, every spiral arm, every glowing core, every billion-star cluster, all of it began with a red dot. A small, mysterious, impossibly bright object that our best telescope barely detected, sitting at the edge of what we can see, in the moment just after everything began. James Webb Space Telescope didn't just find a black hole, it found the blueprint. And the story isn't over, because Kuiper's LRD Z9 is the oldest confirmed, but there are candidates beyond it. Objects so far away that confirming them requires technology we're still building. Somewhere out there, at the very edge of what light can carry across 13 billion years, is the first one, the original. And James Webb Space Telescope is looking. If you want to understand what these little red dots actually are, and how a single prediction made 16 years ago just unlocked this entire mystery, that video is on screen right now. Watch it. The two stories connect in a way that will change how you see every image of the night sky.